December 2023 UGC Net Electronic Science Question Paper Solutions Part 4, that is from question number 76 to question number 100. First question, for an X-band radar operating at 12 GHz, given operating frequency is 12 GHz, the value of minimum pulse replication frequency which may be used to unambiguous measure the wind velocity in a tornado with wind speed of 360 km per hour is. In the question they have given operating frequency is 12 GHz. The wavelength corresponding to 12 GHz is 3 into 10 power 8 by 12 into 10 divided by 12 into 10 power 9. That is lambda is equal to C by F. So its value is 1 by 40 meters. Given velocity 360 kilometers per hour, convert this velocity into meters per second. 360, 1 kilometer is 1000 meters and 1 hour is 3600 seconds. So its value is 360 by 3600, 1 by 10, 1000 by 10 is 100 meters per second. Now we need to calculate minimum pulse repetition frequency. PRF, its value is 4, V maximum 100 divided by wavelength. So wavelength is 1 by 40. It is 1600 16,000 hertz, that is 16 kilohertz. So correct answer is option 1. Next question, in cylindrical coordinates the Laplacian equation holds the following expression. So for Cartesian coordinate system, Laplacian equation is del square V is equal to dou square V by dou x square plus dou square V by dou y square plus dou square V by dou z square. Similarly, for cylindrical coordinate system, del square V is equal to 1 by rho dou by dou rho dou V by dou rho plus 1 by rho square dou square V by dou phi square plus dou square V by dou z square. Similarly, in spherical coordinate system, del square V is 1 by r square dou by dou r square dou V by dou r plus 1 by r square sin theta dou by dou theta sin theta dou V by dou theta plus 1 by r square sin square theta dou square V by dou phi square. These are the corresponding Laplacian operators in Cartesian, cylindrical and spherical coordinate system. In the question they have mentioned cylindrical coordinate system. So correct answer is option 3. Question number 78. For an uniform line charge of 8 nanocoulomb per meter lying along the z-axis, the electric field at a radius of 3 meter from uniform line charge is given by. So we need to calculate the electric field. The formula is electric field intensity due to infinitely long line charge. So due to infinitely long line charge, electric field intensity is rho L by 2 pi epsilon naught r, where rho L is charge per unit length or line charge density coulomb per meter, r is a radius or the distance between the point and the line charge. Similarly, for infinite shear charge is rho L by 2 epsilon naught. In the question they have given line charge. So line charge density rho L is equal to 8 nano 10 power minus 9 coulomb per meter. Electric field at a radius of 3 meters. So given point distance is 3 meters. Electric field intensity E is equal to rho L by 2 pi epsilon naught r. Here rho L is 8 into 10 power minus 9 divided by 2 pi. Epsilon naught is 8.854 10 power minus 12. The value of epsilon naught is 8.854 into 10 power minus 12 and given radius is 3. On calculations, its value is 47.934 volt per meter, and the direction of electric field is in arrow direction. Units of electric field is volt per meter. So correct answer is option 3. Question number 79. The minimum receivable signal in the radar receiver which has an IF bandwidth of 2.5 megahertz and 9 dB noise figure is, and the temperature given is 290 Kelvin. So given temperature is 290 Kelvins, bandwidth is 2.5 megahertz, noise figure is 9 dB. So convert this 9 dB into linear scale. 10 log of noise figure base 10 is 9 dB. Therefore f is equal to 10 power 0.9. Its value is 7.943. Now minimum receivable power P minimum is KTB into F, noise figure in linear scale. That is K value is Boltzmann constant 1.38 10 power minus 23 joule per Kelvin. Temperature is 290 Kelvin. Bandwidth is 2.5 megahertz 10 power 6, and noise figure is 7.943. 7.943. So its value is 7.947 into 10 power minus 14 watt. So approximate answer is 7.97 is approximately nearest answer is 6.946 into 10 power minus 4. Correct answer is option 2. Next question. The peak carrier voltage is 150 volts. Given carrier voltage VC is 150 volts and resistor is, the value of resistor is 200 ohms and the modulation index is 0.5. The total power in amplitude modulated signal. So here the signal is amplitude modulated signal. So based on the carrier voltage and the resistor, we need to calculate carrier power PC. So carrier power PC is equal to VC square by 2R. Here carrier voltage is 150 into 150 by 2 times of resistor 200 ohms. Therefore carrier power PC is 56.25 watt. Now we need to calculate total power in amplitude modulated signal. So total power in AM signal is PC into 1 plus mu square by 2, carrier power plus sideband power. Here the carrier power is 56.25 into 1 plus mu square. Mu is modulation index 0.5 whole square by 2. So its value is 63.28125 watt. 63.28. Correct answer is option 3. Next question. Which of the following is true? Statement 1. FM has finite number of sidebands as well as carrier. So FM is having carrier plus infinite number of sidebands. Statement 1 is incorrect. In FM signal, the total transmitted power always remains constant, but bandwidth increases with the depth of modulation. Statement 2 is correct. The total power of FM signal is constant, and the formula for bandwidth of FM signal is 2 into beta plus 1 into FM. Beta is depth of modulation. If beta increases, bandwidth increases. Statement 2 is correct. Third statement, in AM, amplitude of carrier component remains constant. So statement 3 is wrong because in amplitude modulation, the amplitude of carrier varies in accordance with the amplitude of message signal. Fourth one, statement 4, for eigenvalues, the carrier component of FM waves appear completely. Statement 4 is incorrect. Statement 1 is wrong, 3 is wrong, 4 is wrong. Statement 2 is the correct answer. This is a spectrum of FM signal. Spectrum of FM signal consists of carrier component FC and infinite number of sidebands. The bandwidth of FM signal is 2 into beta plus 1 FM. Beta is modulation index, that is delta F by FM. If beta increases, number of sidebands increases. That is bandwidth also increases. Next question, the modulation index of AM wave is given by. So the modulation index of AM wave is given by modulation index mu of amplitude modulated signal is the ratio of amplitude of message signal to amplitude of carrier signal, or it is V maximum minus V minimum by V maximum plus V minimum in AM signal. The given graph is amplitude modulated signal. In this given graph, amplitude of carrier is varying in accordance with the amplitude of message signal. Since it is an amplitude modulation, here the peak value of AM signal is V maximum and minimum value of AM signal is V minimum. V maximum minus V minimum by V maximum plus V minimum give modulation index of amplitude modulated signal. Correct answer is option 3. Question number 83. For a two transistor model, the value of alpha 1 plus alpha 2 is equal to. In the two transistor model of silicon controlled rectifier, the device is modeled by using two bipolar junction transistors connected in such a way that transistor has current gain of alpha 1 and transistor 2 has current gain of alpha 2. The condition for device to conduct is alpha 1 plus alpha 2 greater than or equal to 1 for the device to conduct or latch on, and the threshold value is alpha 1 plus alpha 2 is equal to 1. So correct answer is option 3. The value of alpha 1 plus alpha 2 is equal to 1. Question number 84. The circuit given is three phase half wave control rectifier using thyristors T1, T2 and T3. For such a circuit with resistive inductive load, the average output voltage at firing angle alpha. The firing angle is alpha. Average output voltage is V average is equal to 3 root 3 by 2 pi Vm cos alpha. If firing angle alpha is 0, output voltage is maximum. V average maximum is 3 root 3 by 2 pi into Vm. So correct answer is option 3. The value of maximum average output voltage occurs at delay angle alpha is equal to 0 and it is given by 3 root 3 by 2 pi Vm cos alpha. Correct answer is option 3. Next question. If any root of characteristic equation of a system has positive impulse response, g of t is unbounded. That is, if roots of characteristic equation are lying on the right hand side of S plane or impulse response is unbounded, then the system is unstable system. That is, unbounded output for bounded input. The system produces unbounded output for a bounded input, or roots lying on the right hand side of S plane, or impulse response is unbounded. Correct answer is option 4, unstable system. Next question. Here the transfer function of a system is given as shown in the figure. We need to calculate, here the block diagram is given, we need to calculate the transfer function. The given circuit has no feedback loops. The given circuit has no feedback loops, only it has three forward paths, that is indicated with red color, green color, and yellow color. Three forward paths are there. Using Mason's gain formula, the transfer function is C of S by R of S is equal to sigma pk delta k by delta. P1 is G1, G2. Path 1 is G1, G2, and the value of delta 1 is 1. P2 is, this is the second path indicated with the green line, that is 1 into G2. Gain is G2, delta 2 is 1. P3 is, this is the path P3. The gain of P3 is 1. And delta is 1 minus sum of loop gains of individual loops plus sum of products of loop gain of two loops. Here there is no loop, therefore the value of delta is 1. Now the transfer function C of S by R of S is equal to P1 delta 1. So P1 delta 1 is G1 G2 into 1 plus P2 delta 2. P2 value is G2, delta 2 is 1 plus P3 delta 3. 1 into 1 is 1 divided by delta. Delta value is 1. Now the transfer function is G1 G2 plus G2 plus 1. Correct answer is option 4, G1 G2 plus G2 plus 1. Next question. The mechanical summing elements that are used to convert applied force into displacement are called, that is force summing devices. Force summing devices are primarily used to convert applied force or pressure into measurable displacement. Force summing devices. Whereas force integrating devices often use summation of electrical signals or integration of mechanical elements into a single system. Summation of electrical signals or integration of mechanical elements into a system. These force summing devices are known as elastic elements and are mechanical components in pressure transducers. Correct answer is option 1. The mechanical elements which are used to convert applied force into displacement is force summing devices. Question number 88. A current of 300 microampere produces full-scale deflection in an instrument whose coil resistance is 75 ohm. What will be the value of shunt resistance if the measurement is to measure current of 5 ampere? So given full-scale deflection current 100 microampere, and we need to calculate the value of current, that is capital I. The value to be measured is 5 ampere. Coil resistance is 75 ohm. The multiplication factor M is equal to I by Im, that is measured, the current to be measured is meter range extended current is 5 ampere and full scale deflection current Im is 300 microamperes. Its value is 666.666. Now M minus 1. M minus 1 is 1666 1666.666 minus 1, that is 1665.6666. It's the value of M minus 1. Now the value of shunt resistance to be connected, RSH is equal to Rm by M minus 1. So Rm is 75 ohms by M minus 1. Its value is 1665.6666. Here the correct on calculation the value is 0.00450027. So approximate value is 0.0045 ohms. 0.0045 ohm. This is the value of shunt resistor to be connected across the instrument to extend the meter range up to 5 amperes. Question number 89. The device used to convert non-electrical quantity into electrical signal is called. So answer is transducer. So transducer converts non-electrical quantity into electrical quantity, whereas inverse transducers converts electrical quantity into non-electrical quantity. Transformer. Transformer is an electric device that uses the principle of electromagnetic induction to transfer energy from one circuit to other circuit. Transformer converts AC signal to AC signal without changing the frequency. Oscillator. Oscillator is a positive feedback. Oscillator is an positive feedback electronic circuit in which input signals are fed back in phase with the input signal and feedback signal are in phase with each other. An oscillator is a circuit that creates continuous alternating waveform from a DC source without any external input. So there is no external input to the oscillator and it uses positive feedback. Next is inverter. Inverter is DC to AC converter. Rectifier is opposite functioning of inverter, that is AC to DC converter. Here correct answer is option 3, transducer. Question number 90. The value of the resistor value required to use 0 to 1 milliampere ammeter with an internal resistance of 25 ohm as 0 to 1 voltmeter. Here we need to convert 0 to 1 milliampere ammeter into 0 to 1 volt voltmeter. Okay. According to Ohm's law, the total voltage drop across entire series combination is V is equal to I into Rs plus Rm. Given full scale current I is equal to 1 milliampere and internal resistance is 125 ohms and the desired voltage range is 1 volt. Apply Ohm's law here. 1 volt, that is equal to 1 milliampere, 1 into 10 power minus 3, and the value of internal resistance is 125 ohm. We need to calculate the value of series resistance Rs is 1000 minus 125. Rs is equal to 1000 minus 125, it is 875 ohm. We need to connect a series resistance of 875 ohms with an ammeter of in series with the ammeter of 0 to 1 milliampere to use it as an 0 to 1 voltmeter. Correct answer is 875 ohms, option 3. Question number 91. MOSFET in linear region, the current is. These are the current equations for N channel and P channel MOSFET. In cutoff region, the current in cutoff region when VGS is less than threshold voltage, drain current IDS is 0. In linear region or triode region or ohmic region where VGS greater than VTH and VDS less than VGS minus VTH, or VGS minus VTH greater than VDS. This is linear region or ohmic region or triode region. This is a condition. In this case, IDS is equal to mu n COX W by L VGS minus VTH into VDS minus VDS square by 2. Similarly for P channel MOSFET where VSG greater than VTP. These are the current equations. In saturation region, the current is IDS is equal to half mu n COX W by L VGS minus VTH whole square 1 plus lambda VDS. These are the current equations in cutoff region, triode region and saturation region. The question given here is current in linear or triode region. ID is equal to mu n COX W by L VGS minus VTH into VDS minus VDS whole square by 2. Now the condition is in a linear region, the condition is VGS minus VTH greater than VDS. This current expression can be approximated as mu n COX W by L VGS minus VTH into VDS. This term can be neglected because VGS minus VTH greater than VDS. Correct answer is option A, and option B. Next question. A typical voltage transfer characteristics of a realistic NMOS inverter as shown in the figure. The noise margin for low signal and high signal levels are. This is a noise margin curve. Noise margin is amount of noise that can be added to the worst case that can be added to a worst case output such that signal can still be interpreted as valid input. Noise margin low is this is a noise margin low. It's a difference between VIL minus VOL. Noise margin high is VOH minus VIH. Noise margin low is VIL minus VOL. Noise margin high is VOH minus VIH. So correct answer is VIL minus VOL. Low noise margin. High noise margin is VOH minus IOH. Correct answer is B and C respectively. Next question. If okay. Next question. Question number 93. If Z into L is total channel area and C suffix PAR is a total input parasitic capacitance, then for microwave performance, the cutoff frequency can be defined as. So cutoff frequency is Gm by 2 pi total capacitance. Gm by 2 pi into C total capacitance. So total capacitance C total is equal to parasitic capacitance C dash PR plus CCA, where CCA is Z into L into COX. Z into L into COX. COX is oxide capacitance per unit area, and Z into L is area of channel, total area of channel. So correct answer is option A and option D respectively. Option 4 is a correct answer. Correct formulas are A and D. Correct option is 4. Here total capacitance is not considered. Similarly in CGD it forms a Miller capacitance. It is also invalid answer. Question number 94. Consider the following statement. The 5 statements are given from A to E. We need to find the correct answer, correct statement. We need to identify the correct statement. So statement A, the origin of punch through phenomenon is the lowering of barrier near to the source. Statement A is correct. The punch through phenomenon indeed originates from lowering the potential barrier near the source due to extension of drain depletion region into the channel. So statement A is correct. Statement B, for a long channel device, the drain bias can change the effective channel length, but the barrier at the source end remains constant. Statement B is correct. In long channel devices, the drain bias can affect the effective length of channel, that is via channel length modulation, but source barrier remains unaffected. Statement B is correct. Statement C, for short channel device, the barrier is no longer fixed. In short channel devices, due to proximity of source and drain, the barrier is no longer fixed, making it susceptible to punch through. Statement C is also correct. Statement D, lowering of source barrier do not cause any injection of extra carriers. Statement D is wrong. Lowering of source barrier causes injection of charge carriers do cause any injection of charge carriers. Statement D is wrong. Lowering the source barrier can cause the injection of charge carriers. Statement E, the punch through condition normally occurs inside the bulk region of semiconductor. It is not inside. The punch through condition typically occurs through the bulk of semiconductor, not along the surface or inside. So correct answer is option 2. A, B, C statements are correct. Question number 95. Which of the following statements are correct? The charge coupled device is a linear scanning system. Statement A is correct. The charge coupled device is a non-linear scanning system. So it is wrong. It is linear scanning system. Statement C. A charge coupled device can be used as a shift register. Statement C is correct. Statement D. A charge coupled device cannot be used as photo detector. It is wrong. A charge coupled device CCD can be used as photo detector. So correct answer is option statement A and C, that is option 1. Charge coupled device can be used as photo detectors. In fact, this is one of the main functions in managing the main functions in imaging sensors. They convert light into charge. Charge coupled devices used in analog shift registers. Charge coupled devices primarily linear scanning systems, not non-linear. Next question. For a given circuit shown below, which are correct two equations of mesh current? So KVL, apply KVL, three loops are given. This is loop 1, loop 2 and loop 3. Three loops are given. Apply KVL in each loop. KVL is the sum of voltages around the closed loop is 0. So consider loop 1 and apply KVL in loop 1. So current is entering like this, entering in negative terminal. So minus 150, positive and negative, 3 I1, again positive and negative, 4 I1 minus I3. So the current I1 and I3 are in moving in opposite directions. 4 I1 minus I3 plus 100 volts entering positive terminal plus 100 volts plus 5 I1 minus I2. This is direction of I1 current and this is the direction of I2 currents. 5 I1 minus I2 plus 74 volts is 0. On rearranging this expression, we will get in loop 1 KVL is 12 I1 minus 5 I2 minus 4 I3 is equal to minus 24. Option statement A is correct. Next KVL in loop 2. In loop 2, minus 5 I1 minus 6 I3 plus 5 plus 6 plus 7 I2. So 5 plus 6 plus 7 is 18 I2 minus 5 I1 plus 18 I2 minus 6 I3 is equal to 12 volts. So correct answer is 5 in statement B. 5 I1, statement B is wrong. It should be minus 5 I1 minus 6 I3. So statement C is also incorrect. So B is incorrect. C is, so for C it is KVL in loop 3. Apply KVL in loop 3. In loop 3, minus 4 I1 minus 6 I2 plus 4 plus 8 plus 6, 18 I3 is equal to voltages. That is minus 206 plus 100, minus 191 minus 15 plus 100, it is minus 106 volts. So statement 3 is related to KVL in loop 3. It is correct. Therefore, correct answers are A and C, KVL in loop 1 and KVL in loop 3. Question number 97. In admittance parameters, Y11. So Y11 is short circuit input impedance. So it is correct. Y11 is input impedance. Admittance parameters are short circuit parameters, short circuit input impedance. It is short circuit input admittance, not impedance. It is admittance. So statement 1 is wrong. Y22 open circuit output admittance. So these Y parameters are short circuit parameters. Statement 2 is also wrong. It is not open circuit, it is short circuit parameters. Next, Y21 is short circuit transfer admittance. So Y21 is short circuit forward transfer admittance. Y21 is I2 by V1. So C is correct. Y12 Y12 is open circuit transfer admittance. So these Y parameters are short circuit parameters. It is not open. Next, Y12, Y21 are both short circuit transfer admittances. Correct. Y12 is reverse transfer admittance. Y21 is forward transfer admittance. Option C, statement C, statement E are correct. Statement A, B, C are wrong. So here in the given options, none of the options are correct. The correct statements are only C and E. For a two-port network, the Y parameter equations relate to the input and output currents, to input and output voltages. That is, I1 is equal to Y11 V1 plus Y12 V2. I2 is equal to Y21 V1 plus Y22 V2. In matrix form, I1 I2 is equal to Y11 Y12 Y21 Y22 V1 V2, where I1 I2 are input and output currents, V1 and V2 are input and output voltages. This Y11, Y12, Y21, Y22 are admittance parameters, short circuit parameters are Y parameters, units are Siemens or mho. Next question. This question is related to the properties of impulse function. Let us see the properties of impulse function. Continuous time impulse function. One is scaling property. Delta of at is equal to 1 by mod a delta of t. Convolution property. X of t delta of t minus t naught is equal to x of t minus t naught. First derivative delta of t is d by dt of u of t. Sampling property. Integral minus infinity to infinity x of t delta of t minus t naught is equal to x of t naught. If t naught value is 0, then integral minus infinity to infinity x of t delta of t dt is x of 0. Sampling property. Next is product property or multiplication property. X of t delta of t minus t naught is x of t naught delta of t minus t naught. If t naught t is 0, x of t delta of t is x of 0 delta of t. Statement 1 is related to product property. X of t delta of t is x of 0 delta of t. That is, statement 1 is correct. Statement 2, it is related to sampling property. X of t delta of t dt is x of 0. X of 0. So keep it 0 here, t is equal to 0 here. We will get integral 1 to 2 1 into dt delta of t dt. So its value is clearly not equal to 4. Statement B is incorrect. Statement C, x of n minus 0.5 whole power n u of n, that is x of n is minus 0.5 minus 1 by 2 whole power n u of n is an energy signal. Its energy is finite. It is an energy signal. In the option they have given not an energy signal. So statement C is wrong. T into delta dash of t is equal to minus delta of t. Distributional identity t into delta dash of t is equal to minus delta of t. Statement D is correct. Next statement E, x of t is equal to t into u of t is neither an energy signal nor power signal. So for t into u of t, energy is infinity. For t into u of t, power is also infinity. Therefore, it is neither an energy signal nor power signal. Statement E is correct. Therefore, correct statements are A, D, E. Correct answer is option 3. Next question. The output voltage of summing amplifier or inverting configuration with the three inputs VA, VB, VC and input resistors RA, RB, RC is for a three input inverting summing amplifier with three inputs V1, V2 and V3 and input resistors R1, R2, R3. Feedback resistor is RF. The output voltage is V0 is equal to minus RF by R1 into V1 minus RF by R2 into V2 minus RF by R3 into V3. So statement 1 is incorrect. In subtractor circuit, output voltage is equal to the voltage applied to non-inverting terminal minus voltage applied to the inverting terminal. Statement B is correct. The narrow bandpass filter is a notch filter. So notch filter is a narrow band stop filter. Narrow band stop filter, that is notch filter. It rejects a narrow range of frequencies. So statement C incorrect. It is narrow band stop filter. VCO, voltage controlled oscillator is called as frequency to voltage. Statement D is also incorrect. Voltage controlled oscillator converts voltage to frequency. It is not frequency to voltage, it is voltage to frequency. Statement D is incorrect. Statement E, the all pass filter provides unity gain with predictable phase shifts for different input frequencies. All pass filter, the gain of all pass filter is unity for all frequencies, whereas the phase shift is frequency dependent. All pass filter have frequency dependent phase shift and the magnitude is equal and the value of magnitude is 1. Equal gain usually unity. Statement E is correct. So correct answers are B and E. Correct statements are B and E. Therefore correct option is 4. Next question. IDSS is a maximum drain current for JFET with open circuit connection from gate to source and VDS is greater than VP. So drain to source current ID is equal to IDSS, that is maximum current flows through JFET when gate source voltage VGS is 0, that is gate is short circuited to source or open circuited with no bias. Here they have mentioned only open circuit. So statement A is wrong. Statement B, the magnitude gain corresponding to voltage gain of 100 dB is, so 100 dB is 20 log base 10 into gain is 100 dB. Now it is gain is 10 power 5. So option B is correct. Statement B is correct. Option statement C, for any inverting amplifier, the input capacitance will be increased by a Miller effect capacitance sensitive to gain of amplifier and feedback capacitance CF between input and output terminals of active device. Statement C is also correct. Statement D, the flight frequency transistor small signal AC equivalent circuit model, that is hybrid pi, is known as Gia-Colcott model. Statement D is correct. Statement E, the transistor bias configuration having high stability factor are stable. Statement E is incorrect. Having low stability factor is more stable. High stability factor less stable. Low stability factor more stable. Statement D, the high frequency small signal model is typically hybrid pi model, not a Gia Gia-Colcott model. Therefore, correct answer is option 3. B, C, D,